So we'll wait for 5 minutes and then start.
Okay, sir. I had a thing to tell that in the Google Drive folder that you have uploaded the slides. I mean, the four slide has not been uploaded.
What happened?
The slides that you uploaded in the Google Drive folder
Mm-hmm.
of the problem solving sessions,
Mm-hmm.
the week 4 slide has not been uploaded, sir.
Okay, we'll check it and
Okay,
upload.
sir.
Yeah. So, any doubt in the last week lecture you want to discuss?
No, sir, everything is all okay. Sir, and I have applied the thing that you told, tan hyperbolic h, and I have got full marks.
Okay. But is that question is there? I don't know.
Yes, that type of question was there in the assignment, sir.
Okay, I don't remember that. Okay, so yeah, let's start today's session. So that is the last session. So whatever the doubt you have to ask, you can ask today because it's the last session. And so the first question is, what is the zeta potential of a particle that displays a mobility of n to the power minus 4 centimeter square second inverse in n to the power minus 2 molar NaCl solution at 20 degrees centigrade, for which viscosity is 0.01 poise, epsilon r is 70 8.5. Hint is assuming solve by assuming that Huckel potential applies. Also, calculate the potential at a distance and nanometer from the surface of the spherical particle of radius 2 nanometer. Solve this question and just let me know. Okay, hello.
Okay, sir.
Is the question clear?
Yes, sir, but I'm not clear with the Huckel potential.
Yeah,
I
it is
mean,
there in the lecture.
okay. I'm searching my notes, sir.
Yeah, it's the Huckel equation. Hello.
Yes, sir, I'm solving.
Yeah, it's the easiest question. How much time you all need?
So 431.8 zeta potential will be
438.8 watt.
uh, zeta potential.
In terms of what?
In terms of SI units, I mean volt.
No, it's wrong. Others? Kaushika? Kaushika, what about you?
Sir, no, sir, I joined late. Just now I came.
Okay. Hello, Zoom user is there.
Yes, sir.
Yeah,
Sir, I'm calculating.
your name is Shweta, right?
Yes, yes, yes.
Yeah.
Actually, I want to change it, but I'm unable to change that. But whatever it is
Okay.
there in the.
Okay. So while I'm waiting for 1 minute, it's an easy question. First part is easy, so let me know if you have solved it. Okay, so let's look at the solution. Solution is we have to use the equation for the mobility, that is
Is
U is
equal
equals to
to C into beta potential epsilon divided by eta.
correct.
Yes.
So we need to find out the zeta, correct? So that is 3 eta u by 2 epsilon. So 3 into eta 0.01 poise.
So we can convert poise into SI units by multiplying it with 0.1.
Yeah, correct. So that becomes Pascal second per poise, correct? Then we have mobility that is given 10 to the power minus 4, and that has to be converted. So that is minus 4 divided by 2 into epsilon is 78.5 into 8.85 into 10 to the power minus 12. Is that what you did?
Yes, sir, but the answer is not matching. I did exactly in the same way.
Okay, we'll check it. So others?
Yes, done in that way, but 10 is to minus 4 for that U mobility. We have to change into meter.
Yeah, that's the assignment. So it is coming 21.5 millivolt.
Yes, sir. Yes, sir. Yes, sir. Now it is matching.
Yeah, now try the next part. Do you know how to do the next part?
So I can try.
Yeah.
Sir, I have a doubt regarding the first part.
Yeah.
Actually it is coming 0.02159 into 10 to the power 5 volts. We can write it as is it megavolt? You have written MV, that is megavolt.
No, it's a millivolt. Millivolt.
Okay, okay. So it will be 10 to the power minus 5.
No. Why?
No, but 10 is
I
to
mean,
minus 3 will be milli, no?
yes, yes, yes.
Do you know now which formula has to be used for the next question?
For next question, we have to substitute the formula psi is equal to psi naught into e to the power minus k's, but the psi naught is not given.
No. So you have to think about it. It is also discussed in the class. Can you relate psi naught with
Catch. That was
can you
the doubt to you.
can you relate psi naught with zeta?
Psi naught which term?
Yes, sir. There is a formula I have found out.
Q, no, for Q we can do that Q
Sir,
is equal to 4 pi epsilon.
found out.
Sir, please explain it.
Yeah, let others has to solve it.
So will it be 0.11 volts?
No. Okay, let's look at the solution. So we need to find out the psi. So we need to find out the psi such that psi is given as Rs by R e to the power minus kappa R minus Rs. So if we have a particle like this, then Rs is this. And we have to find at some distance R, what is this potential? Okay. Is that what you tried, Dipanvita?
Yes, sir. Actually, I tried in the same formula, but I used RSSR and RSRS. I thought that the small r will be the radius and the distance will be RS.
Just know that then the whole point will, how can you use that? It's completely change.
Yes, sir. Yes, sir. I was wrong in
While
that.
while going through the lectures also, you have to look at the lectures in a way that otherwise it's not about just solving the question, it's about the concepts. So why at RS the potential? If you substitute R is equals to RS, then you will get zeta automatically. So that's the main theme of that question. So that has to be understood. So psi you have to substitute. So RS is what? 2 nanometer. Just try it and check it with the solution. So we have to find out at 10 nanometer from the surface of the spherical. So that is R plus. So this distance is actually given to be 10 nanometer. We have to add this part also. So 12 into 10 to the power minus 9 meter, correct? So psi is 2 into 10 to the power minus 9 divided by 12 into 10 to the power minus 9. Zeta is 21.5 into 10 to the power minus 3 e to the power. And what's the value of kappa? Did you calculate the kappa?
Sir, kappa is 30.4. It's coming. No, sir. Kappa inverse is 30.4. I
What
mean
is
the
kappa?
divide one.
What is
Kappa
kappa?
is mm, 328.9.
Correct? Is what I written is correct?
Yes, sir.
Yeah, so just calculate it. 1 by 6, 21.5 p by 6 e to the power minus 3.29 so e to the power of 3.29 is, this value is 0.0372 into 21.5 divided by 6, 0.133 millivolt. I just wait for 1 minute just to check, so that you can check your calculations and check if it is matching or not. Then we'll proceed for the next question. Okay. Hello. Is the question clear? Hello.
Yes, sir. I'm checking.
Kaushika, is the question clear?
Yes, sir. I checked. I got this answer only. 0.133.
Okay. Shweta?
Yes, sir. It
So
is
the
0.
answer is correct, sir.
Okay. Okay. Now let's look at the another question.
Sir, in exam they will provide the digital calculator. No, it will be shown in the desktop, right? There we
Yeah.
can able to calculate this e power
Yeah.
and log.
Yeah.
Okay, sir. Okay, sir.
Okay. So the next question is, consider a spherical colloidal particle of 0.2 micrometer radius positioned at oil water interface. The oil water interfacial tension is 40 millivolt, 40 millinewton per meter. Okay. So find the following. Following for 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . values of theta at which the particle is positioned. That is for the case of theta is equals to 90 degree and theta is equals to 60 degree, and angle theta is defined as this. This is theta, this is oil, this is water. Okay, and this is our radius of particle. So you have to think about it, like if theta is 90 degree, then how the particle will be positioned. If it is less than 90 degree, then where uh, it is more and where it is less. So you have to use that and you have to calculate. First part is surface area of the oil water interface occupied by the particle calculate the surface area of particle in contact with water phase, then calculate the surface area of particle in contact with oil phase. Then you have to calculate the energy required, the energy required to detach the particle from the interface to the oil phase, and calculate the energy required to detach the particle from the interface to the water phase. Okay, so we'll go in a way that first solve this for both the angles, then solve this for both the angles, then go through it. So just try first part and then let me know the answer for this for that. Okay.
Sir, if number D and E, if it is asked that find it in terms of KBT, then we are going to divide it with KBT, right?
Yeah. Okay. Hello.
Yes, sir. I'm trying.
Is the question clear?
Yes, sir.
Okay.
Sir,
Yeah.
sir, I have completed the first part,
Okay.
the A part.
Yeah. For both the angles.
Yes, yes, yes.
Okay. What's this? So how? Let
Sir, I have for cos 90, the answer is 0.25 micrometer square.
Okay.
And for 60 degree, the answer is 0.13 micrometer square. Yes, sir.
Okay. So can you help me in solving it?
Sir, the surface area will be 2 pi r square, 1 minus cos theta.
2 pi r square into
1 minus cos theta.
uh, We have to calculate the surface area of the oil water interface occupied by the particle.
Yes, sir.
Are you understanding what we have to calculate?
Sir, in the lecture, there was two formulas given where we have to calculate the surface area of the particle water, that was 2 pi r square 1 plus cos theta, and the
Yeah.
other one was particle oil, that was 2 pi r square 1 minus cos theta.
Yeah. And this is the third one. That it has nothing to do with these two. So if you see the top view of this, you will see something like this. Top view. So we have to calculate this area. Are you getting this? So
Yes, sir.
this area of this area you have to calculate.
Okay, okay, okay.
So if this is R, and if this is small r, then you have to calculate pi r square. That's it. But you have to relate the r in terms of capital R. If theta is 90 degree, then I know that r is capital R. But what if it is not 90 degree? Hello?
Yes, sir.
Others? Shweta, Kaushika, any idea?
No, sir.
What I'm saying is wrong or not?
What are you telling? It is given in the lectures. Actually, I didn't understood that. There is a smaller portion sir has calculated.
Kaushika?
Sir, how you get this formula pi r square? Are you equating that to and make it is this form? This
No,
one.
if this is the radius of this, uh, so let's say this portion of this is inside the water and this portion is outside the water, that is in oil, correct?
Sir.
So we
Yes,
have to
sir.
calculate the area of this interface.
Okay.
Surface area of the oil water interface occupied by the particle. So this is the only surface area that is occupied by the particle, no? At the interface.
Okay, sir.
Are you
Okay.
getting that?
Yeah, yes,
Sir,
sir.
when the angle is 60 degree, will the formula be pi r square sine square theta?
Yeah, that's the way how you relate R to R. But are you getting what I'm saying? Like
Yes, 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 sir.
the generalized formula is pi r square sine square theta. Okay. Can you calculate it now?
Yes, sir.
And for your simplification, for your understanding, I can relate. So let's say this is the particle, and this is the theta. This is my R. And this is my cap. And let's say this is small r. So can I relate r with r? So how can I relate that? So this is nothing but theta. And this is 90 minus theta. So from here, r is nothing but r sine theta. Okay. And in the same way, we calculate the area for the case, for other cases, like how much it is in water. So you don't need to memorize it. Like you may, if you may confused, then you can just simply solve it and find it. So this part is R, and this is what? This is nothing but R. This is
R square
cos
minus small
theta.
r square.
R cos theta. So this become, so the area of the spherical cap is 2 pi R into this height. So that is R into 1 plus cos theta. So that is for the case surface area for particle water, and surface area for particle oil is, so we have to subtract this part just. This is R, and we have to subtract this. So what we get is 2 pi R square 1 minus cos theta. So you don't need to remember this formula. You can simply just evaluate it. So that is the main theme of this solving this question. I hope the question is easy. Did you get the first part?
Yes, sir.
Yeah, tell me.
For 90 degree, the answer is 0.136 micrometer square. And for 60 degree, the answer is 0.0942 micrometer square.
So pi into, so for 90 degree, that is for case A. For first part, that is pi R is 0.2 into 0.2. What's the value?
0.136.
0.136 micrometer square. Is it matching with others? I think
Sir, but I got 0.1256.
I think the answer is
1256.
0.0127. It's just a simple calculation here. What's the issue? 1 minute, I have to check.
Yes, yes, sir.
Sorry,
0.1256.
it's 0.1256. Yeah.
Yes, sir. 0.1256. I got this one.
And just for second part, S is pi, so same with sine square theta.
0 point.
So sine theta is 60. So 60 means root 3 by 2.
3 by 2.
That is 3 by 2.
3 by 4.
So it becomes 0.0942. Correct?
Sir, 3 by 4. Yes.
So that is correct. Right?
Yes, yes,
Yes,
sir.
yes, sir. Yes.
Okay. Now try quickly second part. Did you understand this? What I just told about this? Hello?
So can you repeat it again? I was solving the problem, so I couldn't see it.
Okay. Others, Kaushika and Shweta.
Yes, sir. Please repeat it again.
Okay. Kaushika,
Yes, sir.
did you get that?
So I got little, but not fully.
Okay. So what I'm saying is, okay, so let me remake this again. So see, if you are having a particle, okay, and it is like that. So this angle is theta, and radius of this particle is r. Okay, so this should be r. Correct. Any doubt with it?
No, sir.
Okay. Now this is the spherical part, and this, let's say that is something, and let's say this is a small r. So if this angle is theta, can I say this angle to be theta?
Yes, yes, yes.
Any doubt, others?
No.
Okay. So if this is theta, then this is nothing but 90 minus theta.
Yes.
Yes.
So applying, so this r becomes simply with projection of r onto r, it is r cos of 90 minus theta, that is sine theta. Correct?
Yes, sir.
Doubt? Any doubt, others?
So repeated this one. R is equal to.
So you are having this triangle, and you
Yes.
know this, that is capital R. So you are looking at the projection of this onto this. That is, so if this angle is theta, then projection of this onto this is this cos theta. Correct?
Okay. Yes.
So this is uh so this is nothing but, so this R is just nothing but the projection of R onto this, and this angle is 90 minus theta. So R cos of 90 minus theta is R sin theta. Correct?
Yes.
Kaushika?
Yes, sir. I got it.
Yeah. So now you have to find the surface area of this. So we know the surface of area of the cap, if you have to find out, we know that is 2 pi r, that is radius of the particle, into h, and h is this. If this cap, if you are considering this cap, then this is h. The surface area of particle water is, that is 2 pi r into h. So h is nothing but r plus r cos. So this is nothing but, if this is r cos theta, this is r sin theta, then this is r cos theta. Did you get that?
Yes, sir.
So then
Yes. Yes.
it is 2 pi r square into 1 plus cos theta. Similarly, the surface area of this cap is H2, so that is oil water, so that is 2 pi r into H2. So 2 pi r, so this is r, so this net is r, and you have to subtract this part. So that is r minus r cos theta, and so it comes out to be 2 pi r square into 1 minus cos theta. Correct?
Yes.
Kaushika? Hello?
Sir.
Kaushik,
Yes, sir. Yes, sir. Yes, sir. Are you
did you
able to
get
hear
that?
me? Yes,
Did you get that?
sir. Yes, sir. Yes, sir.
Any doubt? Any of you?
No.
No, sir.
Okay. Okay, so yeah, just solve these parts quickly and then we'll see. Have you solved it?
Yes, sir. The second part will be particle water, so it will be 2 pi r square 1 plus cos theta.
Yeah. So what's the value?
0.2512. So for cos 90 degree.
Yeah, what? Cos theta
Is
is,
this for is this for cos 90 degree?
I didn't, what you are saying?
Is this for cos 90 degree?
Oh, okay, okay, no, no. For cos 90, it should be just 2 pi r square. So this is what you get?
0.2512.
Okay. For second part,
The second part is 0.3768.
2, 3 by 2. 0 point.
3768.
Okay. Others?
Sir, I got C answers. I got
Okay.
similar answer for B.
Okay, C.
So same answer, sir. 0.2512.
Okay,
Second one is 0.1256.
0.12.
56.
Yeah, correct.
So the formula for particle oil and oil or water is the same.
No.
I mean, the number in number C, it is said that that is the surface area of particle in contact with the oil phase. That means it will be particle oil.
Yeah, this is particle water, then this is particle oil.
Yes, yes.
Yeah.
So, but after substituting 90-degree, we got both the answers same. How come it will be same in both water and oil? Is it correct? It will
Yeah,
be
it's
like
correct.
that, sir?
Yeah, it's correct. So the reason behind this is that if you see,
90-degree.
uh,
So
so 90 degree is only possible when you have a equal amount of area. So then only this tangent become. So if you see, if you find the tangent, then this will subtract 90 degree only if both of these are equal. Did you get it?
Okay, sir. Yeah. Yes, sir.
Anything less than or greater than will change the symmetry.
Okay, sir.
So it is sort of intuitive. Uh, okay.
Okay, sir.
Yeah, let's solve D part.
sir, it's a nanometer square or micrometer square? Nanometer, no?
1 minute. Yeah, the particle size is in micrometer, so it should be in micrometer square only.
Okay, okay, I got it. That one in a nanometer I have written in my question, sir.
Yeah.
Micro-
Can you go above? Because I want to see the question.
Yeah.
Okay.
Sir, in the D part, it will be delta G, DO or DW.
So you are detaching the particle from the interface to the oil phase. So what it should be?
Interface to the oil phase.
Yeah.
Um, so it should be delta G DW. Yes, sir.
So if you are detaching it from the interface to the oil phase, then it should be DO, obviously, isn't it?
Yes, yes, sir. Sir, my answer is 0.005 in 10 to the power minus 12 joules.
DO. What
DO.
multiply you used?
Pi r square into the the surface tension,
Hmm.
pi r square into the surface tension into 1 plus cos theta whole square.
Correct. So pi r square we know that is 0.1256 into gamma oil water. So that is in micrometer square. So this should be 10 to the minus 12. And then we have oil water that is 40 millinewton per meter. That is 40 into 10 to the minus 3 Newton per meter into 1 plus cos theta becomes 0. So this will become this. For the first case, it is this. So this is 40 into 0.1256. So that is 5, 4 into 10 to the minus 15 Newton
Yes, sir, this answer.
meter. So
It is femtonewton, sir. Femtonewton is 10 to the power minus 12.
yeah, let's keep it like this. Is it matching with others?
Yes, sir.
Yes, sir. I am also got the same.
Okay, what about second part?
Sir, is it 2.512?
It should be 1 plus cos theta. So cos theta is half.
Oh, okay, sir. Yeah, I did mistake there. 5.7776.
So it should be 9 by 4, correct? So it should be 11.304. Isn't it? Hello, Kaushika?
Sir, I'm checking, sir, but I got different one. That's why I'm checking.
It should be 9 by 4, correct?
Okay.
Isn't it?
Yes, sir.
But plus 1 will be there, no, sir?
So cos 60 is half.
Yes, sir. Half
Okay,
plus
okay.
1. So it will be 1.5, right? I mean,
Yeah,
3
one.
by 2. 3 by
Yeah,
2,
three.
so it's 9.
Yeah,
so I think it will be
yeah,
6.64.
it's 7.5 only. No, but it should be so it's 1.5 to the power square. It's 1.5 square actually.
So it's
No,
11.4
already done the square
ten to
root.
the power minus 15.
3 square is 9 and 2 square is
Correct? Is it
Yes, sir. Right.
Kaushika?
So no, sir. Can you repeat this one? I'm not. I got confusion over that area 9/4 because
So
one
1 plus
plus. Uh,
1 by 2 square. So that is
3
3
by
by
2.
2 square. So that is 9/4. So this term becomes 9/4. Hello, Kaushika?
okay, sir.
Did you get it?
Yeah, yes, sir.
Okay. Yeah. Then E part.
Sir, here we have to convert everything into radian. The degree part, the degree one.
Yeah,
Hello.
whatever. Yeah. So cos theta. So what is the value of cos theta? Like theta is 60 degree.
Yes, sir. Yes, sir.
So cos 60, either you take it in radian or so the cos theta will be same.
No, I'm
Yeah.
just asking, sir. That's it.
Yeah.
Okay.
So if you detach, so for the case of 90 degree, you will get the same answer. And for the second case, you will get 5.024 into 10 to the minus 15 into 1/4. What you get is 20.096 Newton meter. Correct? Hello, am I audible?
Yes, sir. Yes, sir. Correct.
So any doubt with that? So you see, so as the same amount of area is there, so the same amount of energy is required for the two cases if theta is 90 degree. You see?
Sir,
Yeah,
that e theta equal to 60 degree. I mean the last value.
yeah,
Is it correct? But we have to just divide it 5.024 divided by 4, no?
yeah,
That last
Sir,
one.
it is coming
One.
yeah,
12.5,
One point something.
yeah, yeah.
10 to the power minus 12.
So, but I got
1.25 into 10 to
1.25.
the minus 15.
Yes, sir. I got this only.
Yeah. So that's all for I think for week 8. I hope I have covered all the sections, all the numericals, all the possible numericals. But you have to brush it up, all the concepts till now. So any doubt apart from that, because this is the last session.
Sir, in exam, what kind of question they will ask?
Yeah, so like I don't know. I hope similar kind of questions only.
Sir,
Like
can you suggest us how to prepare for this exams? What kind of book? What is there any material for problem section? Is can you suggest us something?
the only thing I can suggest is I like honestly go through the all the assignments, then all the problems that I have solved in all the sessions. That will make you very clear. I think I have covered different sorts of questions, different aspects of questions also. And then uh, just uh, go through the questions given in that textbook that sir has used, Principle of Colloids by Raj Gopalan. So if you
Okay, sir.
find some numericals there, you can go through that also. And I think that's it. And good amount of going through the lecture notes again or lectures again. That will help you, I
Sir,
guess.
in that book, actually I saw in that book there are so many problems in that each and every unit, but I can't find the answer for that because I just how to say, I solved it, but I have to know whether the answer is correct or not. Where will I go and get the answer for that question, sir? Is
Yeah,
there
I
any
also
separate?
don't have the answers for that also. So
Yes, sir.
I
Because
don't have any
there is.
solution manual for that. So, but I think you can always check it if you so I the important thing is that the concept should be right. If the concept is right, then I think you will get the correct answer. It's about the numerics only. Are you correctly solving that question or not?
Okay,
Uh,
sir.
but there are examples related to that. I think that are enough there, and most of the
Okay.
concepts related to the numericals are also covered in this live sessions. So I think if you just prepare that, that will be good.
Okay, sir.
Sir, I want to ask one question.
Yeah,
Sir, you have used the kappa inverse is short formula that is 3.04 into 10 is to minus 10 z
yeah,
m to the power minus half. That
yeah,
is only applicable when the temperature is 298.
yeah.
Otherwise, we have to go for the general one which we normally use. That is, kappa inverse will be that epsilon naught into epsilon r kbt divided by e squared multiplied with 1000 Na. That one.
Uh, so you can always. So I told you in one of the lecture now that how you are finding that coefficient. So you can
I
also
did it.
relate that
That
coefficient to the temperature also. So
only the temperature is 25 degree. Then only we will apply that formula, right?
yeah. So what you
Kappa
can do is
inverse is
you
equal.
can in the same way you can divide just by this temperature and multiply with the new temperature. So that
And
is
one more thing is that one more condition is 1:1 electrolyte must be present for that.
yeah, I told you, like how to. So if it is 1:1 electrolyte, then what's the formula? If it is not, then what's the formula? But
Okay.
that is also for the 25 degree centigrade. That was discussed in the that lecture for itself that
Yes.
I uploaded, and that where I solved the where I solved it for asymmetric electrolytes.
So I have one more doubt. That
Yeah.
is in the that it is given that in a dynamic light scattering experiment,
Mhm.
this was carried out, and there is a particular temperature, viscosity is given, and density is also given. But
Mhm.
they have given data in two columns. That is x square t into 10 is to minus 10 meters square second, and one is g2 that is in terms of s and t.
Okay.
So how to find out that scattering, the question which is given in that one? I'm not getting that one. It's a second week question actually.
So week second, I think I discussed that also.
I don't think so. No, this one I have attended, we have done it, but not that one. S2. That is light scattering method, two different data has given. Sir has also discussed that, but I didn't able to understand that one, how to calculate the other
This
one.
one, this part.
Yes, sir. Yes,
Yeah,
sir.
so I
This
discussed
one.
this. So you can go through it again. So I told that how to find it.
Uh-huh.
So you G2 is related to G1 like this, and then G1 is related to like this. So B in If it is not given, then assume it's 0, and then you can find out the formula, and then you substitute it and then find out the different D values. I guess that works.
Okay, sir. Okay,
Yeah.
sir. I will go through that.
Yeah. Okay. Anything? Anything else?
Sir, can you give your email ID? If there is any doubt, I can mail you.
Yeah. So
Before
there,
the
my
exam.
email ID is okay. So my email ID is shreyang20@iitk.ac.in. Okay.
Okay, sir.
Sorry, Shreyank. It's Shreyank. So it's Shreyank20@iitk.ac.in.
Okay, sir. Thank you.
Okay.
Yes. Thank you, sir.
Okay.
Sir, the slide that you just now represented, was it of week 4?
Which one?
The slide that you represented just now,
No, this is the current
the
slide. Today's slide.
no, this is not the slide that you showed a bit earlier.
That is the week second, I guess.
Okay, sir.
That is week second, I hope. You may go back and check. I don't remember it.
Yes, sir. It is second week.
Yeah.
Second. Okay, sir. Okay, sir. Thank you, sir.
Okay.
Okay.
Bye then.
Sir, is
Thank
there
you.
any question pattern for exam? This much of question will come
No,
like
actually,
that.
I don't know that. I'm not setting up the question. There are different TAs who are doing that. So I'm not even in contact with them. So I don't know.
Okay, sir. Will the information will come in the future, or while writing the exam time only we can came to know?
Only the while writing the exam, mostly.
Okay, sir. Thank you.
But you will be able to solve that in 3 hours.
Okay, sir.
Okay.
Okay. Sir, I think I hope that question will be asked as it is given in the assignment only.
Yeah, but go through the lectures and just.
Yes, sir. That I'm going through, but still I'm thinking that very different pattern of question because I am not from physics background. So I found very difficult, not from the engineering background too.
Okay.
Sir, yes, sir. Even for me also it's similar. So it's hard for me to find is because you in the first question itself you said that it is in between water and interface, oil and water interface. Why you are suggesting that, so we are came to know okay we can use it, but in exam how can we identify it?
Yeah,
That's
that's
very
why I
hard for
discussed.
us.
So now you understand it, like what I'm.
Yeah, now we can understand, sir, but in exam we are not sure, right?
Yeah, you can. So what you can do is you can go through the lectures again, and whatever you do, if you have any doubt, you can write me, and if need, we can discuss it.
Okay, sir.
So you are
Okay,
from which
thank
background? Kaushika?
I'm from physics background. Physics.
Okay. So you are pursuing what? PhD?
Yeah, yes, sir. I'm PhD.
Where?
Sir, VIT, Vellore Institute of Technology.
Okay. Okay.
Yes, sir.
Sir, I belongs to chemistry background. So just imagine what will give me this assignment.
Yeah, but chemistry is also, so if you are into the colloid science, so it's a surface chemistry. So surface chemistry has a lot of these things.
No, surface chemistry doesn't have these things actually.
But yeah, but I don't think so. Like most of the this colloids and interfacial science. It's a part of surface chemistry.
Yeah. So actually, it's a so I thought that it is a surface chemistry only. For that, I have opted of this subject actually, but
Okay.
now it is.
Yeah, but you can always try and
Yes, sure.
Sir, actually, we are from science background, so we will more concentrate on the theory, not on the numerical part. That's why we feel very hard.
No, I don't think so. That actually we also concentrate on the problem part, but this is too much physics for me. Too much engineering for me.
Oh, for me. It's not in physics one. It's mostly mathematical.
yeah,
So
but
many maths formula.
like without mathematics, you can't do physics.
Yes,
Yeah,
actually,
yeah. True, true.
So maths
Mm.
and physics are very correlated.
interrelated.
So there is no use
Yes.
of physics without maths.
Okay.
Mhm. Yeah. Okay, so if you have any doubt,
Okay,
you can always mail me. We can discuss it.
okay.
Okay,
Thank
sir.
you, sir, for that.
Thank you, sir. Yes,
Okay,
sir. Thank you, sir. Thank
bye.
you so much.
Sir,
Yes.
may I leave the meeting?
Yeah, yeah, yeah.
Sure.
Okay. Thank you, sir.
Okay, welcome.
Yes.
Sir, please upload it by tomorrow.
Yeah, yeah, sure. Anyway, PDF, I am just uploading them.
Okay.
Okay.
Sir, we can leave.
Yeah, yeah.
Thank you, sir.
Actually, sorry, sir. My laptop got stuck. I can't able to leave. I don't know.
Okay, okay.
That's why I was trying.
Okay, okay.
Uh,
What about Shweta? Yeah.